Let's solve these problems. The idea here is predict products. These are electrophilic aromatic substitution reactions. So your first step would be recognizing what is the reagent and what is it doing. So first reagent here is bromine and iron tribromide. So this is a bromination, and you will be installing a bromine here. So now, looking at the substrate, next step will be analyzing what type of groups do we have activating or deactivating and how they direct the future electrophilic aromatic substitution. So let's see this. Here we have a methoxy group that is activator, and it does direct ortho-para. Now, the other group. So let's write this down. This is activator, ortho-para director, and the sulfonic acid group is the activator. Now, when you have a situation, you always need to choose then the most activating group is the one that is going to be determining say, region selectivity, where the reaction is going to happen. So most activating is the methoxy group, and this is going to direct the substitution here, ortho and para. Now notice that the para position is right next to, this position is right next to the sulfonic acid, which is large. This is also next, so the preferred location is actually going to be this one that is farther away from this group. So let's write down the product. Again, where the three arrows are showing is the ortho and para positions relative to the methoxy group. But you also need to consider steric factors, not only electronic. So electronic, the methoxy is going to direct ortho-para, but because of the steric hindrance, you don't want to be close to a large group. So your preferred location is going to be the other ortho position. So your major product is going to be here. The reaction, as we said at the beginning, is a bromination. So that's your major. And you will have other two products, but notice that one that is not going to form is this one here. Notice that it is going to be in between two groups. So that's the largest steric hindrance. So if you did have another product, it needs to be here, where you do have a steric hindrance. Oh, it's not that what I wanted to draw. I want to draw here. Here's the sulfonic acid, keeping the same type of drawing. Here's your methoxy, and here you will have the bromine. But this is minor. It's too close to that. And the other product in between these two groups is unlikely to form. So this is your major product. So let's do the same analysis for the second reaction here. Now, what do we have? This condition is nitric acid, sulfuric acid. So this is a nitration reaction. You will be installing a nitro group on the aromatic ring. Next step, analyze what is your the type of group that you have. Electronic effects and steric effects need to be considered. So now, here you have two groups that are actually deactivating. But I'm going to redraw the carboxylic acid like that. So remember here that you have a dipole and also you have resonance showing you that this is delta positive, so it's electron withdrawing. Halas are deactivators, but these are the weakest deactivators. So when you are between two deactivating groups, the region selectivity, the position of the product, is going to be determined by the weakest deactivator. So deactivator here, deactivator, but halas are weaker deactivators. And halas are the exception. Most deactivators will be meta-directing, but halas are ortho-para directing. So you're going to have here, ortho is here. The other ortho position is occupied, so you have these two positions. Now, the next consideration to determine what is the major and the minor product is sterics. According to the electronic effects, then it will be either these two places indicated by the arrows. But we see that when it is paired to the bromine is far away from any other group, so that will be your preferred location. So less steric hindrance. So here you will have bromine. Here is your carboxylic acid. And then the next group, which is the nitro. Remember, we first need to establish what is the reagent used for. This is to do a nitration. So this is your major product. Again, electronic and then steric effects. Minor product, I'm going to draw then the other that has the nitro group next to the bromine. So ortho to the bromine. Unlikely to form too much steric hindrance. Okay, so now we have the analysis for this two. Let's do the last one. Here we have fuming sulfuric acid. Fuming means this is saturated with SO3 gas. This condition is to install a sulfonic acid group at the aromatic ring. So next step, again, we know what we're installing. We're installing one of these, sulfonic group. Now, what is this group? Nitro group is a strong deactivator, very strong deactivator. And chlorine, all of the halides, we said they are weak deactivators. And so the regiochemistry where the substituent is going to be entering is determined by the weakest deactivator. And halides are, as we said before in the previous example, these are ortho-para directing. So this is going to be ortho to the chlorine, para to the chlorine. Now you need to analyze sterics as well. So these three positions, notice that in the position here, this is in between these two groups, which is unlikely to form due to sterics. Now you have the ortho to the chlorine here or para to the chlorine. So the nitro group is a little larger, so I say the major product is going to be ortho to the chlorine. So we have our major product is going to be your installing a sulfonic acid is a quite large group. So you don't want to have this. It's not going to go in there because it's too much steric hindrance. So we have less steric hindrance at that position. So that's your major product. And your minor is going to be next to the nitro group. So SO3, this is my sulfonic acid. And chlor here. Minor. Yet, when you're doing these problems, analyze what is the reagent used for, what is the group that I am installing, what is your electrophile in this reaction. And next, when you have polysubstituted aromatic compounds, you need to analyze where are these groups activating, deactivating, and how they are directing, and then determine what group is going to be likely determining what is the rigid selectivity of that. And that will allow you, that with the steric effects, will allow you to determine what is the major product and the minor product in this synthesis.